although it's announced as smart cities, I thought it's a popular term. I also want to make it more generic about urban decision making, better decisions in urban environments, and that is actually in a city or municipality, and everybody is talking about smart cities. I haven't talked to any mayor that says, I don't want us to be smart, so that's also a PR term. But it's becoming more and more quoted, so it's good to link it to the smart city team. And I think you're all familiar with the problem of urbanization, that more and more people are coming into the cities. And if you actually look at what kind of strains on the resources that has a serious impact. And this is that, to give you an idea that where these growths are actually happening. And also in Africa, I think in 15 years' times, the population in the cities are doubling. So we have a big issue to dealing with this amount of increased pressure on the scarce resources. We all know that water and energy in South Africa are not sufficient to cope up with this kind of growth. So we need to come up with smarter ways or better ways to deal with these resources in an efficient manner. And we have, besides the resources, we also have other problems in with urbanization, and South Africa is dealing with many of them as well, but these are many problems that offer a cure and being tackled by a domain-dependent solution. So in order to deal with water, people tend to focus on the water domain, while as in an urban environment, you actually need a global and integrated solution. So the actual challenge is to maintain and expand and create new sustainable environments was in the beginning, as in the first talker also indicated, while we need to maintain the quality of life. So what do we do with obtaining these resources? And my background is from an ICT background, so I like to also focus on what can that kind of technology provide, assisting the decision makers. And there have been many discussions, and also in yesterday's talk in the ICT track, there was a lot of presentations on utilizing the data. And the data that is becoming available, because a lot of devices are becoming generators or sensors for data. They produce at low cost lots of volumes of data. People also like to Twitter and use social media. You saw on the application for the mobile app to report potholes, for instance. That data is becoming hugely available in an unstructured manner, and it's very dynamic. There's a lot of things happening at the same time. We're not only using in situ measures, but also through the more and more information available from satellites, observations, etc. We can also have a bigger picture as well as pictures from on the ground. The trends from all this ICT and whatever it is around gathering more data and more information, but you have to think about what is useful for your decisions. And you integrate actually the real world by sensing it in all means. You can have a model. We saw this on the ports and on the brakes to analyze and understand. And actually you can forecast what will happen if you have understanding, good models about the temperature, what will happen with the weather, but also with planning on expansion of settlements in cities and what kind of cities and what that will mean. And what kind of decisions you make can actually play, and then you can simulate and adjust your models and also inform the decision makers. And in that whole scene, you can actually also use modern techniques as serious gaming, so that you have multi-party stakeholders playing in such an environment, and they can learn from each other's priorities. And then actually you want to implement this in your real world to see what's happening. And this can also be used for training and simulation, what we saw before, also with the ship maneuvers. But also as a city manager, to know what kind of decisions, what impact it has in multiple other domains, is very good to have multiple domains in such an environment. And the term smart city or smarter and everything is what is actually meant by smart. And I use this very simple, is that to be more efficient, to be more effective, and to be innovative. So if you use these kind of combinations, then you actually, if you use the available information for better decision making, and better, you can also argue what is better in certain ways, but there is a way to see what your decision, what the value and the impact of your decision is. So before we start with technology, we actually need to see what kind of decisions need to be made, what's the impact, what's the value, and then you can actually see if it's worth investing, improving such decisions, and what kind of information or what kind of data you actually need at what scale to make that better informed decisions. We are not here about automating any decisions in the city. We provide a dashboard or provide insight to the decision makers. And the decision makers are not only the managers of the city, but also the citizens themselves. So for instance, if you use your GPS navigation that is real time, it's actually telling you what's the best route given any congestion on some other aspects, or where there is emergencies, etc. So it is also for citizens that live, residents, but also for tourists and visitors that actually come to the city where the smarter decision making has impact on. From a technical point of view, it is more or less a challenge how to source and deliver all this and store this and manage this amount of data in an effective manner so that you can actually gather from different domains that data. And that's the challenge, because even I'm also engaging with the city of Johannesburg on the smart city strategy and implementation. I'm part of the advisory board. I'm chairing actually that. But what you see is that there are very much silos of entities that are not even talking to each other how to exchange the information they have. So we can say on a technical base you can actually connect it, but in practicals it is quite difficult to exchange this data and use this data in a good manner. And then the question, of course, is how to process and interpret this data with some time constraints and also the accuracy. What you can do is within a domain you need specific good planning and decision making, but if you across the different domains it becomes even more difficult. So what you actually need to build is some binding glue that can actually form all the systems that are around there. And of course you could argue for, if you are a big multinational, buy our software, our solution and entire stack, but then you create a lock-in. Some cities have chosen for one vendor and all the solutions will be based on that, but that is also a risky operation, because the provider then owns the city as future decision making. It's better to go for an open system where you can plug in existing tools and also make sure that you use standards to do that. But you need to make sure that all the new developments and new sensors, etc., are able to talk in the end to that system. And the data that needs to be integrated is often of unstructured manner, so you really need to know how to make use out of that. And the algorithms for the decision making are mostly domain dependent, but in the end you need to relate it at a high level to gain new insights. So we propose also to have a scalable, open and interoperable solution and platform that is secure and transparent. Because if you hijack, for instance, we saw this morning these UAVs that can actually monitor, etc. If somebody operates and hijacks such a plane remotely, then you can do all kind of other stuff. The same in a city. If your system is based on where maybe crimes or activities are, and people report it, but if your sensor is being hijacked and people generate a lot of false alarms, so the police will move into that area so that other areas are underserved. So these are the business models for criminals. So smart city is also opportunities for others in a different way. So we have to think about that as well. So what we actually came up with within the CSIR, and different units contribute in different domains to this system, is that you actually need to sense your environment, communicate about it in different ways, trying to manage your data, and then to utilize that data. Analytics and visualization, also especially for decision makers, also a large amount of data need to be brought to the essential things, what you actually need to know to make your decision up. And for every environment that might be different. There's a lot of work being needed to do that in an attractive manner, but also in a manner that makes actually sense out of the data, so that people can actually act on it. We have this nonlinear interconnection is actually a stack on this, where you can actually, on each level, have technology developments, and different people work on different environments. But to have this really running in a city, you need to have all the elements applied to this. So, to give you an idea, this is just a snapshot, and there are many more ideas and areas where we have this smart technology and the platform that we currently being developed and with other partners applied to different areas in mining, in fire, so fire detection, ocean oil spills detection, energy, water safety and security, settlement detection to expanding of growth, all needed for an urban environment to be connected. And I'm going to illustrate a few things in a specific domain and then give some examples where you actually, if you combine it, is good to make better decisions. We have also international test beds, so we for instance, monitor the environments in Barcelona through our international collaborations. We know the logistic transport systems all over the different cities. We can use the same platform for that. But the challenge here is, in order to have these different domain-specific solutions connected to each other. And what we say, okay, we are building such an environment, or open platform, or integrated stack, or how you different middleware and how people different call it. Let's reuse as much as possible for sharing the data and improve the domain decisions. Give you one nice example from Singapore. This is actually a camera, multiple cameras at the same crossing. And they are not sharing it to each other. The rationale behind is they don't trust other entities within the city, but also the legal application of the usage of the footage is different. For instance, sometimes you cannot use the faces, sometimes you cannot use the number plates for that particular purpose. So in rather to avoid this all administrative, they say, let's put another solution on there. And to be frank, this is also not happening in sharing this video footage in Johannesburg, because the road agency is not allowed to obtain the camera footage from the police. So while in 2010 they actually did that as part of a big initiative. So also there you see, and initiatives, for instance, in the smart city of Johannesburg are not only the network that's being rolled out with Wi-Fi free hotspots for a lot of citizens, where maybe also all these centers can make use of, but also the integrated operation and command center, which is actually driven to integrate all kind of happenings in the city, footage cameras from the police, from the road agencies, from energy efficiencies, city power. They are all trying to connect and see what is happening in the city. So that's a good attempt to integrate this, but it requires a lot of like collaboration effort. On example, what I'm going to give on the energy is some of the work that we've done here to make energy more efficient, the usage. So peak load shifting, load balancing, all these kind of aspects by measuring and also able to switching on and off devices in buildings, etc. What we actually do for the utility provider is based on the information we have, so to make long-term projections for where our settlements, automatic settlement detection from informal as well as formal, to predict what is going to be the energy load at the long term, as well as short-term projections. So by measuring a lot of energy, so where is there any peaks to be expected in the next half hour? Do we need to switch off maybe some areas? We all maybe heard already this morning that Eskom was already indicating again some load balancing of load shedding issues maybe today. So in order to avoid switching off whole areas, it's better to send out messages to a system in your house or in your building to switch off non-essential appliances. And that can be technically done if you have the infrastructure in house. So we are experimenting with that about this energy efficiency. And of course, renewable energy sources, local generated and local usage, you can also play with this in the smart grid environment. But also for the homeowner, we get dashboards, and we develop that to see what your energy consumption is, prepaid meters to can actually see how much, if you consume this way, your energy, the bill will be, of your meter will be empty before the end of the month. And we're doing, it's difficult to see, but we can measure in systems all the energy usage from the sensors, and that on a fine grade scale, so we can aggregate that. And we're actually working with Eskom on a pilot to demonstrate and validate this in real life. It is very interesting to know that the energy can have much impact on other domains. I was last week in Maputo, where there was a blow up of a transformer, and the city, part of the city, I think 25% of the city, became out of power, which is not uncommon, but this was a transformer and it will stay out for the next 3 weeks. But it affects all the water pumps to build up the pressure. So now 2 million people are already out of water for like 4 days, and that creates political unrest. So you can imagine, if you don't link the different domains to each other and share the information, you can create some hazards and which you could have foreseen or even planned for. Just on the water side, I just want also to give you an example. We're also busy measuring and see what the water pressures and water usage are, because at different levels you can do that. At the national level, to see where the water leakage are, you can use systems for that, but also down on a low level. And actually what we measure, the pressures and sensors, and they communicate to see where the potential water losses might be. And what you typically see is this: if this is a normal pattern, then you can see, hey, on the steady state at night, there is still a lot of water being consumed somewhere. Either toilets are running, or even worse, pipes are broken. And I think the CSIR campus as a whole has one point where we actually measure the water from the city municipality, and there is quite some. We are on the top 400 users of water in the city. And we actually consume water at certain peak points where actually nobody should use water. So we need to investigate, for instance, where that it is. And in cities, as also with Joburg Water, they also have some problems with leakages and maybe non-technical losses where people use the water without being like measured. So what you can do is use this kind of information to be able to predict and use and compare and model that. And also see on certain time peaks if there are faulty measures or maybe also illegal taps. And this is actually also a picture from the CSIR itself, that we already discovered some finer grained problems. The solution is that these are nice and good examples for an individual domain. What we actually need in a city is to make sure that they are connected to each other, so that there's a relation between the different domains, so that the investments are actually utilized in the most effective manner. One other example is a bit more extreme. You also have environments that are very harsh, temperature-wise, but also communication-wise. It's very difficult to communicate. We have sensor communication wireless underground. But what we did is also for the mines, to make these devices that can actually measure distances and also changes in temperature. You see here on the right a device that is actually measuring on thermal images and also using acoustics to see if there's any rock problems that can actually deform or actually fall down, and measure also the height of the ceilings. And this can be measured with bridges as well, to make sure if there's any deformation and changing in the structures. If you have this kind of information available at your fingertips, you can actually plan for maintenance and rather be proactive than reactive. And I think in the city environment for refurbishing, it is quite essential to make sure that the buildings that are already there are maintained in a proper manner. Actually, this is my last slide, so it's good, given the time, I tried to speak up. Just a bit about for the people that are not familiar with the CSIR. I think we, especially on the smart city environment, it is there are cities, and I've been talking also to many municipalities that are being bombarded by offerings by service providers that have biases. They want to make sure that you buy their product. So we can advise them, and also as a neutral party, and actually collaborate together with industry on these projects. And throughout the days, you've seen here that we have a wide range of capacity and expertise at the CSIR, supporting the building environment as well as any specific domain that is needed. Thank you.